Hello friends, in this video we are going to discuss a numerical on the energy band diagram. So the numerical is given like this: an n-type semiconductor having uniform doping is biased as shown below. So this is an n-type semiconductor which is biased by this applied voltage V. So we have to find the energy band diagram for this biased n-type semiconductor. So generally what we know, for an unbiased semiconductor, for an unbiased n-type semiconductor, so let us take an n-type unbiased semiconductor. So this is a n-type unbiased semiconductor. According to the energy band diagram, we know that the band diagram will look like this. This is the conduction band, and this is the EC energy level, and we will have a valence band, and this is the EV energy level. Since it is a n-type semiconductor, so the Fermi level will be near to the conduction band, EF for n-type. Now if we apply a bias according to the question, so this is the diagram of the question where an external voltage has been applied in this direction. Now in the band diagram, this y-axis denotes the energy of the electron. That means if we move from down to upward direction, then the electron energy will increase. Similarly, if I go downwards from the up direction, then the whole energy will increase, and this is the distance. That means as we move upward, the electron energy will decrease. Now in the question, they have given an external potential such that this terminal is of negative potential and this terminal is of positive potential. That means the electrons that are near this negative potential will have high amount of energy, but the electrons which are near the positive terminal will have low amount of energy. That means the energy band diagram will look like this throughout the semiconductor. So this will be the conduction band, and this will be the valence band, and this will be the EV, and this is EC. So this side electron since have higher energy, so they will have a position in the high, and these electrons have some lower energy, so they will be in this lower position, and the Fermi level will be near to this EC energy level. So this is the EFN. So this is the total band diagram of the semiconductor N type under the biased condition. So this is all about this problem. Thank you.